have the first question of exercise 3.3, which is we have to find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. So if ax square plus bx plus c equal to 0, then the relationship between zeros and the coefficients are, if alpha and beta are the zeros of the polynomial, then we would get the sum of zeros equal to minus b by a, which is the negative of coefficient of x by coefficient of x square, and the product of 0 alpha into beta is equal to constant term by coefficient of x square. If this is the first one, which is x square minus 2x minus 8, we equate it to 0 to find the zeros. So we would get the zeros 4 and minus 2. If we add both of the zeros, which is 4 plus minus 2, we would get 4 minus 2, which is 2. And in fact, minus b by a, which is, if we try minus b by a, then what is b here? B is minus 2. So minus of minus 2 by 1 is 2. So sum of zeros is in fact minus b by a. And if we check the product of zeros, it is equal to c by a. If, I mean to say, product of zeros here is minus 8 and c by a is minus 8 by 1. So product of zeros is equal to c by a. Take the second one, 4s square minus 4s plus 1 equal to 0. Here we get the zeros as 1 by 2 and 1 by 2. Sum of zeros alpha plus beta is equal to 1. And here minus b by a, which is minus of minus 4 by 4 is also 1. And product of zeros 1 alpha into beta is 1 by 2 into 1 by 2 is equal to 1 by 4. And in fact c by a is also 1 by 4. And in third one, we have 6x square minus 7x minus 3 equal to 0. Instead of finding the zeros, if I directly tell you to find the sum of the zeros, you would do a alpha plus beta equal to minus b by a. And minus of minus 7 is 7, and sum of zeros should be minus 7 by 6. And in fact, if you add 3 by 2 and minus 1 by 3, you would get 7 by 6. And product of zeros here, it should be equal to c by a. So minus 3 by 6, I mean alpha into beta equal to minus 3 by 6, which is minus 1 by 2. And in fact, if you multiply 3 by 2 and minus 1 by 3, 3 would get cancelled and you would be left with minus 1 by 2. Fourth question, we don't have constant term. So we do have b and a. So sum of zeros alpha plus beta is equal to minus b by a. So minus of 8 is minus 8 by 4, we have sum equal to minus 2, and 0 minus 2 is actually minus 2, and product of zeros is equal to c by a. Since we don't have a constant term, c equal to 0, so 0 by 4 is equal to 0, and indeed 0 into minus 2 is actually 0. And fifth one, we have t square minus 15 equal to 0. Here we don't have coefficient of x. So therefore, alpha plus beta is equal to minus b by a. Since b is equal to 0, sum of zeros would be 0. And in fact, plus root 15 and minus root 15, the addition would be 0. And product, if we come to product, alpha into beta equal to c by a. And c here is minus 15 by a here is 1. And indeed, if you multiply plus root 15 and minus root 15, you are left with minus 15. And last one, we have 3x square minus x minus 4 equal to 0. And like any other question, we get zeros equal to minus 1 and 4 by 3. Addition you would get, so alpha plus beta addition you would get minus b by a. So minus of minus 1 by 3, which is 1 by 3. And multiplication of zeros alpha into beta equal to c by a. So minus 4 by 3 would be the answer. Second question of exercise 3.3. We have to find the quadratic polynomial in each case with the given numbers as the sum and product of its zeros respectively. So in the previous question we have seen that, let's say, if ax square plus bx plus c is equal to 0 is a quadratic polynomial, then minus b by a would be the sum of zeros and c by a would be the product of zeros. So if I divide each term in this equation by a, then I would get x square plus b by a into x plus c by a is equal to 0. If I write this plus b by a into x as minus of minus b by a into x plus c by a is equal to 0. We can see that minus b by a is the sum of the zeros and c by a is the product of zeros. So lastly we can get that x so p of x would be x square minus sum of zeros into x plus product of zeros would be the polynomial. In the first case we can see that the sum is equal to 1 by 4 and product is equal to minus 1. So if I substitute both of them in the equation, then I would get x square minus 1 by 4 into x minus 1, so and equal to 0. And if I multiply both all sides with 4, then the polynomial would be 4x square minus x minus 4 is equal to 0. This is the quadratic polynomial in the first case. Second case, we have sum is equal to root 2 and product equal to 1 by 3. So x square minus root 2 into x plus 1 by 3 is equal to 0. And if I multiply by 3, I would get 3x square minus 3 root 2x plus 1 is equal to 0. The third one, we have sum equal to 0 and product equal to root 5. So in the third case, I would get x square minus 0 into x plus root 5. So the quadratic equation would be x square plus root 5 is equal to 0. Next one we have sum equal to 1 and product equal to 1. So the polynomial would be x square minus x plus 1 is equal to 0. And next fifth one we have sum equal to minus 1 by 4 and product equal to 1 by 4. So if I substitute it, I would get x square minus of minus is plus, so plus 1 by 4 into x plus 1 by 4 is equal to 0. If I multiply all sides with 4, I would get 4x square plus x plus 1 equal to 0. Next, last one, sixth one, we have sum equal to 4 and product equal to 1. So the answer would be x square minus 4x plus 1 is equal to 0. Third question of exercise 3.3. We need to find the quadratic polynomial for the zeros alpha and beta given in each case. It is similar to the second question of exercise 3.3, but in that question, they directly give the sum and product. In this question, they give zeros and we need to find the sum and product to find the quadratic polynomial. So as we learned, p of x equal to x square minus sum of zeros into x plus product of zeros. So first question they gave 2 and minus 1 are the zeros. So sum would be 2 minus 1 is 1 and product would be minus 2. So the polynomial would be x square minus 1 into x minus 2 is equal to 0. And if I simplify and write x square minus x minus 2 is equal to 0. Next second one we have root 3 and minus root 3. So sum would be 0. And if I multiply, plus into minus is minus and root 3 into root 3 is 3. So product would be minus 3. So the polynomial would be x square minus 0 into x minus 3, which is x square minus 3 is equal to 0. Next one we have 1 by 4 and minus 1. So sum would be minus 3 by 4 and product would be minus 1 by 4. So if I substitute it, x square minus of minus is plus 3 by 4 into x and minus 1 by 4. If I multiply by 4 on all sides, I would get 4x square plus 3x minus 1 equal to 0. Next, last one we have 1 by 2 and 3 by 2. So sum would be 1 plus 3 by 2, which is 4 by 2, which is equal to 2. And product would be equal to 1 into 3 is 3 and 2 into is 4. So product would be 3 by 4. So if I substitute it, I would get x square minus 2x plus 3 by 4 is equal to 0. And if I multiply by 4, I would get 4x square minus 8x plus 3 is equal to 0. Fourth question of exercise 3.3, we have to verify that 1, minus 1, and 3 are the zeros of the cubic polynomial, and to check the relationship between the zeros and the coefficients. So let the cubic polynomial be p of x, which is equal to x cube minus 3x square minus x plus 3. And to check if the given numbers are the zeros of the polynomial or not, we substitute the values in x, and if we get the value as 0, then it is a 0 of the polynomial, otherwise it is not. So to check if 1 is the 0 of the cubic equation or not, or cubic polynomial or not, substitute x equal to 1. We have p of 1 is equal to 1 cube, which is 1. 1 square is 1, so minus 3, minus 1 plus 3. So minus 3 plus 3 is 0. 1 and minus 1 is 0, so we get the value as 0. Therefore, 1 is the 0 of the polynomial. Next we have minus 1. So minus 1 cube is minus 1, and 1 square is 1, so minus 3. Minus of minus 1 is plus 1, and we have plus 3. Similar to the above, minus 3 plus 3 is 0, 1 minus 1 0. Since the value is equal to 0 when we substitute x equal to minus 1, minus 1 also is the 0 of the polynomial. Lastly, we have 3. So 3 cube is 9. So 3 square is 9. 9 into 3 is 27. Next we have 3 into 9 minus 3 plus 3. So 3 into 9 is 27. So 27 minus 27 minus 3 plus 3. So 27 minus 27 is 0. Minus 3 plus 3 is also equal to 0. Since we got the value as 0, when we substitute x equal to 1, minus 1 and 3, all the three numbers are the zeros of the cubic polynomial given. And if we come to the second part of the question, they told to check the relationship between the zeros and the coefficients. So to check the relationship between zeros and coefficients, let's take a cubic equation as ax cube plus bx square plus cx plus d equal to 0, and its zeros being alpha, beta, and gamma. In the quadratic equation, the sum of zeros is, if the quadratic equation is ax square plus bx plus c, the sum of zeros would be minus b by a, and product of zeros would be c by a. But in the cubic equation, if this is the cubic equation, sum of zeros is alpha plus beta plus gamma would be minus b by a, and sum of zeros taken two at a time would be c by a, and product of zeros would be minus d by a. In quadratic equation, we have only two relationships, but in the cubic equation, we have three relationships. So, if we compare this equation with the given equation, we have a equal to 1, b minus 3, c minus 1, and d 3. 1 minus 3 minus 1 3. So, we have this a, b, c, d values. Next, to check the relationship between, I gave the values as minus b by c by minus d by a. To check if it is true, let us add all the zeros. So minus 1 minus 1 is 0. So sum of zeros is 3. Sum of zeros taken 2 at a time, which is minus 1 minus 3 plus 3. We have sum of zeros taken 2 at a time, is value is minus 1. And product of 0 is minus 1 into 1 is minus 1, and into 3 is minus 3. So sum of zeros we got as 3. Sum of zeros taken 2 at a time we got as minus 1, and product of zeros we got minus 3. And if you substitute a, b, c values here, you would get minus b by a as minus of minus 3 by 1 is 3, and c by a, which is minus 1 by 1, which is minus 1, and minus d by a, which is minus of 3 by 1, is minus 3. If we check, alpha plus beta plus gamma here is minus b by, which is equal to 3, and when we added all the three zeros, you also got 3. Next, alpha beta plus beta gamma plus gamma alpha equal to minus 1, and here also when we added zeros taken 2 at a time, we also get minus 1, and product of zeros is minus 3. So if it's a quadratic equation, the sum of zeros would be negative of coefficient of x by coefficient of x square, and the product of zeros would be constant term by coefficient of x square. In the cubic equation, sum of zeros taken one at a time would be negative of coefficient of x square by coefficient of x cube. Sum of zeros taken two at a time would be coefficient of x by coefficient of x cube, and lastly product of zeros would be negative of constant term by coefficient of x cube. That's it. Hope you understood the question. For more such solutions, subscribe the channel. Thank you.